Okay, here we are again. This time we're talking about, well, this lesson is basically going to be about just a brief information on the difference between a alkaline perm and acidic perm. A real brief definition, real brief difference is this. We know on the pH scale between 1 through 14, in the middle is 7, which is neutral. And then anything below 7 is acidic. Anything above 7 is the alkaline scale. Now we know the reaction that takes place on the hair strand with these two different types of perm. Basically, the difference is, we mentioned before, that acid hardens and contracts, and alkaline softens and swells. But we just want to add a little bit more information to that definitions and try to get a little bit more specific on what's the difference between an alkaline perm and an acidic perm. Remember, you have different pH levels of alkaline, you have different pH levels of the acidic. Some acidic perms take on the same reaction as an alkaline by softening and swelling. It just all depends on the pH of the hair. Again, we know the hair and skin pH is between 4.5 and 5.5. So anything above that will cause that hair to soften and swell because it is higher than the pH of that particular hair. So if it's higher than that, it's going to cause it to soften and swell. So anything out of the range of acidic on that hair, that's the pH for the hair, it's going to cause that type of reaction. But basically, let's look at the difference, some major and some specifics between the acidic and the alkaline perm. Let's look at the book. I'm going to face this book back and forth just a little bit. Alright, so we have what we call an alkaline wave or a cold wave, which is the name of the perm. Got the alkaline wave or cold wave, known as, they're both the same thing, developed back in 1941, the book says, and they have a pH of 9.0 to 9.6 using ammonia thioglycate, ATG, the book calls it. That's the reduction agent in there, the ammonia thioglycate, as the reducing agent. And that process is at room temperature without addition of heat. Now, remember, we know that the exothermic and the endothermic, one needs the addition of heat, one doesn't need the addition of heat. So that's one type of permanent wave, the alkaline wave or the cold wave, with the reducing agent of the ammonia thioglycate. That's what it is, thioglycate. Help me remember that. Ammonia thioglycate. Okay? Then you have the acid wave, which is also known as the glycerin monothioglycate. Okay? Glycerin monothioglycate. It's in your book. If I'm pronouncing it wrong, let me know about it the next time you see me. Help me out. Okay? Alright, so, but it says the main ingredients in the true acid and the acid balance waving solution is the glycerin monothioglycate. Okay? That's the acid wave. That's the main ingredients in that. And it has a low pH. Alright? It says although it is a primary reducing agent in all acid waves, it may not be the only one. So there are some acid waves that have an additional reducing agent, but that's the primary reducing agent, and the acid wave is the glycerin monothioglycate. okay? And the true acid wave, the acid balance wave, all the different types of acid wave. Alright, so that's the main difference between the alkaline and the acid, the reducing agent. Again, there is more difference we can talk about, but this thing right here I'm talking on doesn't give me a whole lot of time to go into detail. But we want to look at the difference in the reducing agents. That's what makes them work in the chemistry makeup of it, okay? The alkaline wave reducing agent is the ammonia thioglycate, okay? Ammonia thioglycate, which is on the pH level, and reason is alkaline is past that 7. It's at the 9.0 to 9.6, okay? But then in the acid wave, the reducing agent is the glycerin monothioglycate, which is a low pH. Again, pH 7, below that, 7 acidic, above that, you get into the alkaline. Although that's the main reducing agent in the acid wave, it could have another one. Could have more than one, which it really won't go into detail right now. But then you get into the true acid waves, which has the pH of 4.5 to 7.0. That's the true acid wave. Then you get into the acid balance wave. But take the time to look in your books on page 574, where it tells you the difference excuse me, between acidity and the alkaline on the pH scale, and that will give you a better idea of what we're trying to describe today about the difference of the alkaline wave and the acid wave. Okay, I'm going to read this. I'm just about done, but time is running out. Since acidic solution contracts the hair, you may be wondering how a true acid wave with a pH of 7.0 can cause the hair to swell, right? Although the pH of 7.0, which is neutral on the pH scale, a pH of 5.0 is neutral for hair. Okay, the pH of any substance is always the balance of both this acid and alkaline. Even the stronger acid also contains some alkalinity. Alright, so that's why that may swell a little bit, because the pH of hair is 5.0. The pH of a true acid is 7.0, which is above 5.0. Okay, that's about all I'm going to cover right now. Basic difference on the acid alkaline wave. Read the book, get a little bit more specific information. Go to the chart about the acidity and the alkalinity, and you'll see the difference. But remember the reducing agents. The reducing agents and the alkaline, again, is ammonia thioglycate, and then the reducing agent and the acid wave is glycerin monothioglycate. Okay, got it? I'm trying to get it too. See you next time.